In this video, we're going to talk about finding the equation of a line. So with a lot of these problems, we're going to be given different bits and pieces of information and different forms that information is presented to us in, and we need to use that to create something brand new from that given information. So to begin this, we do want to do a little bit of setup work for ourselves and bring in one or two new things here that are going to be helpful in this process. The first part with that is talking about the point-slope form of linear equations. Now all this is just an alternate starting place for linear equations. It's in no way different in terms of it's a completely different equation from the slope-intercept that we saw previously in 4.5. It's just a different way of displaying a linear equation compared to what we've seen previously. It does require that we know how to calculate the slope, and it requires any point that is on the line. This right here is where the real flexibility and power of the point-slope form comes into play. If I know the slope, great. That's always a good starting place. That doesn't necessarily tell me a lot of extra stuff about the problem, though, in terms of where it's going to be positioned on my graph. The other form that we worked with, the slope-intercept form, requires that we have the y-intercept specifically to jump to an answer, versus the point-slope form allows us to use any point of any kind anywhere on the line before we graph it. So we have our general equation written out right here. Y minus y1 equals m times the quantity x minus x1. In this equation, m represents the slope, which we referenced and went through in section 4.4. And the x sub 1, y sub 1 represents a point on the line, and that is generally given to us in the problem. We cannot just randomly guess at a point that is on the line because we don't know if that point actually is or is not on the line. So the main use of this point-slope form, and this is where, if you are taking notes on any of this, the highlighted parts I think are the ones that are worth writing down. This one right here is very much worth taking note of. An equation can start in point-slope form and, very commonly, get rewritten into slope-intercept form. And we see this happen quite a bit when we are actually going through and finding and creating equations. So this is a very common occurrence, and I would not discredit using the point-slope form for situations like that show up in problems. Now before we dive into our process, I do want to give a quick summary of our different forms that we have here, because we've talked about and seen a couple of them so far. So we have three main forms of linear equations. We have the slope-intercept form. We covered that in 4.5. We now have the point-slope form, showing up here in 4.6. And it isn't always talked about, but we have seen it a few times. It's called the general or standard form of linear equations. And we have that listed down here. ax plus by equals c. We had this show up a few times in the 4.5 problems when we were doing some rewrites. Now the main things that I want to show between these forms are kind of these little arrows in between here. So we can rewrite between these three forms as much as we want, though I will say that there are some recommendations that I have for how we do this and which things rewrite accordingly. If we are starting with something in point-slope form, I recommend we start there and rewrite from point-slope form into either slope-intercept form or rewrite into the general or standard form. So start in point-slope and end up in one of these other two. If you're starting in one of these other two forms, the general or standard form, or the slope-intercept form, then I would say it's reasonable to go back and forth and rewrite between these two terms, or these two forms, I should say. The reason I recommend if you start in one of these two forms, you stay in one of these two forms, is because if you want to rewrite into point-slope form, we need to know a point on the graph other than the y-intercept. And that could require a lot of extra unnecessary work that we just don't need to do. Or, depending on the situation, we don't have time to do. Maybe it's a test or something like that. So the big thing to focus in on is I start in point slope form, and I rewrite into one of these other two forms. It's very common, it's completely expected, it's a very good practice to get into. We generally like to write things into slope-intercept form from point slope, so I would get used to that being a pattern of behavior and pattern that we use for starting in something and rewriting into something else. And we'll see a couple examples of that here a bit later on in the video. So bringing us back to our notes over here, let's go through our process on how we actually create the equation of a line. So regardless of the information given to you, maybe it's just a quick one sentence, maybe it's a paragraph of stuff, whatever it is, always start with step one here, determining the slope. If you are ever unsure of what to do, finding the slope is by far the best starting place with any of these problems. Now, there's a lot of places and a lot of information that we can be given and things we can reference, places we can reference to help us determine the slope. Maybe it's given to us explicitly. Hey, the slope of your new line is going to be -1/3 or +2. That can happen. Sometimes we're given 2 points and we need to calculate that using our information from section 4.4 to do that. Or we are given information regarding another line, a completely separate line, and we are told our line is parallel or perpendicular to that. This would be using our 4.5 information to have that come into play and find how that relates to our new equation. The next thing that we need to do is we need to identify a point and label it as x sub 1, y sub 1. It does not matter which point we use, as long as we have the input and output values labeled correctly. That's the biggest thing that shows up with this. We then plug that point, whatever it is, into the point slope form that we have right up here, and then we are going to solve that point slope form for y, and the result will be written out in the slope intercept form. So this is the general recommendation that I have as a process that we use to go through these things. It should also be stated as we're going in here, if you determine the slope and one of the points is the y-intercept, fantastic. You can skip a lot of this process and jump right to the slope-intercept form. I'm going to try and scroll it over here. Jump right to the slope-intercept form because you know the slope, you know the y-intercept. You can just plug that thing in and no extra work necessary. If you're unsure, however, if you have the y-intercept and how to work that properly, that's perfectly fine. The point slope form will work with y-intercepts and it will still lead you to that slope-intercept form all the same. A couple of quick reminders as we are going through these. The horizontal line, and every single horizontal line that we will see is always of the form y equals a number, and it always has a slope of 0. A vertical line is always of the equation x equals a number, and its slope is undefined. Remember these slopes in here because these are universal for all horizontal or vertical lines respectively. So let's take a look at the 4 examples that we have listed right down here, and let's see how we can create some equations out of the given information. In our first example, we are asked to create a line through the points 3, 1 and 5, 6. We were asked to write our final answer in slope-intercept form, y equals mx plus b, so we've got to make sure that we aren't done until we have it in that final form there. So as for our process, first step says to determine the slope. That's always a good place to start with any of these problems. So I have 2 points here. Now remembering back to the 4.4 material for determining the slope between 2 points, I need to label each one of these x1, y1, x2, y2, or essentially point 1 and point 2. however you'd like to label those. And now that we have this, we can plug our known values into this equation, and then we'll solve for our slope from there. Okay, so we are getting a slope of 5/2. Fantastic. We aren't done, but at the very least we have the slope of this line. Now our next step would tell us identify a point and label it as x sub 1, y sub 1. Well, either of these 2 points will work. I already have one of them here labeled as x sub 1, y sub 1, so I'm just going to use this one. So using our point slope form, writing that thing out in its general form here, I'm going to plug in the slope that I just found right here. So that's going to give me 5/2. And then for x sub 1, y sub 1, I'm just going to plug in the numbers inside of parentheses like I did when I was plugging things in for solving for the slope. And what I'm finding when I do this, now I've got a whole bunch of stuff written out here. I am now following step 3. I've just plugged that point into the numbers into our point slope form, and now I'm going to solve this equation for y. So I'm going to try and get y all by itself on one side, again referencing the 2.6 material to make that happen. So I'm going to go through and do that until I have this thing in slope-intercept form. And here we have our final answer, our final equation, as y equals 5/2x minus 13/2. We're okay with fractions showing up even for this b value. That is to be expected. Do not shy away from that. Do not think that is something you're doing wrong. That does happen a fair amount of the time. And of course, we really like having fractions written in here for our slope. Looking at our second example, we are asked to create the equation of a line through the points 1, 4 and 6, 2. So this is going to be very similar to what we did with our first problem. We are again just going to be labeling our points x1, y1, x2, y2 because we need to find the slope of this thing to begin with. So we have our equation for the slope. We have everything labeled as we need to. We'll go ahead and plug these numbers in and solve for the slope here first. Okay, so we have our slope of -2/5. We aren't done, but at the very least we have the slope figured out. Now we have not been given the y-intercept, so we cannot jump to any final answers here. That's fine. We are going to go through and write things out in our point slope form, get the general equation down here. And then we're going to plug things in for the slope, and then for x1 and y1. For the sake of just showing that we can do this, I'm going to use this other point, 6, 2, and plug that in for our x and y values here. You could just as easily use these ones, but I just want to show that we can do this with whichever one we labeled here. So we'll plug those values in, and then we'll work this out to slope-intercept form. And here we have our final answer for the new equation we've created as y equals -2/5 x plus 22/5. Example 3 is switching things up on us just a little bit, so we might need to adjust what we're doing. We are told to create a new linear equation that is parallel to y equals negative 1/2 x plus 15, and through the point 1, 4. Okay. As we did with our previous problems, we want to start with finding the slope. So we need the slope of our brand new equation. I've not been given 2 points that are on our brand new line. I've been given a different line, and I've been given a point. So I can't exactly work with the y2 minus y1 over x2 minus x1 method that we did with our first 2 examples. But I'm instead told that our line is parallel to this other line. Remembering back to the 4.5 material, if I have 2 lines that are parallel to one another, what does that tell me about the slopes of those 2 lines? Well, that means that the slopes are going to be the same as one another. So, the slope of the given equation, it's not our brand new one, but the slope of this given equation is going to be the same slope that we are going to use in our brand new equation. Make sure we are including the number and the sign in front of it. Now, based on this, great, I have the slope and I have a point. I can ignore this equation entirely. It is now completely useless to me. If I were to plug 1 and 4 in for x and y in here, have I actually created a brand new equation? No, I've just plugged a point into a random equation that's been given to me. I have not created something brand new. But now I have my slope, I have a point, and lo and behold, this is where mathematicians were super creative with their naming. If I have a point and I have a slope, man, it's almost like there's a form for that. It's our point-slope form. So we can write that out down below here. And then we can plug things into this equation accordingly and solve for our final answer and get it into slope-intercept form. And here we get our final answer to be y equals negative 1/2 x plus 9 over 2. Our fourth and final example is having us find the equation of a line that is perpendicular to y equals 4x minus 7/8 and through the point 0, negative 6. So again, we want to start with finding the slope of this thing. Always a great starting place with any of these problems. So I've not been given 2 points, so I need to work off of other given information in this problem. We are told that our brand new equation is perpendicular to a given one. Remembering back to our 4.5 material, if I have 2 lines that are perpendicular to one another, that means that the slopes are negative inverses of one another. Meaning, if we were to write this thing out, I think we had our previous ways of writing it was like this from our notes. So, if I'm starting within a slope right here, I would change the sign and I would flip the fraction. So, if I've been given a slope here of 4, in the given equation, my brand new slope is going to be the negative reciprocal of 4. So instead of being a positive, it's going to be a negative. And then 4 is the same as saying 4 over 1. So flipping that, it becomes 1 over 4. So now I have my slope of negative 1/4. Excellent. Now I need to, with that slope established, determine what's the rest of this problem going to be. I'm going to take a look at the point that I've been given, and I can label this thing as x1, y1 like I did previously. However, do we notice anything special about this point and any other points that we've been working with up till now? Well, as we're looking at this thing, we have an x value of 0. And we have a y value of some number. That means that we have actually been given the y-intercept here. And if we've been given the y-intercept, that means we now have the slope and we have the y-intercept. We can just plug the necessary information right into the slope-intercept form and get our final answer of y equals negative 1/4 x minus 6. And we didn't need to even use point-slope form. And we get to our final answer. As a recap of everything we covered here in the 4.6 material, we learned about our new form, the point-slope form, for linear equations, what each part of that represents. And this is just an alternate way of starting with these linear equations, which we can use to rewrite into slope-intercept form or other forms later on. And again, this is a very common occurrence to have that show up and expect that to show up. We also covered our three different forms that linear equations can be written in, and also noted the different ways that we can rewrite between those different forms. Again, I think starting in point-slope form and going into slope-intercept is probably the most common one that we see. We also had our process for going through and creating the equation of a line if we are going to use the slope-intercept form, though there are some variability, there are some possibilities that can show up where we aren't going to use the point-slope form depending on information that's been given to us. Last part with our notes with this. Remember, we do have horizontal lines and vertical lines that can show up. And remember the corresponding slope of 0 and undefined slope for those as well. And then we had 4 examples that we went through of finding the equation of a line given some information. I want to give a very, very, very big warning to everyone with examples 3 and 4. A lot of people will use the information about our line being parallel or perpendicular to a given equation accurately, and then continue working with this given equation in the problem. At most, with a given equation, we are going to use the slope to help us find our slope, and after that, we completely ignore this equation in its entirety. We use all the other information in the problem to create the rest of it, like we did with 3 and 4. So we'll scroll down here, and if you do want to try a couple problems for yourself, I have some extra practice ones right here. You can pause the video and give those a try. Make sure you have everything in slope-intercept form with fully reduced fractions. We'll scroll it down for the answers for these. Hopefully you're getting something very similar. Had some tricky ones here showing up with the group 3 problems. So if you did notice, again, those special forms, horizontal lines and vertical lines, they can show up with these problems all the same. But that's going to be everything, and kind of a wrap on stuff for 4.6 and all of Chapter 4.